Good evening, everyone. Welcome to our monthly Minnesota night skies live presentation, exploring our Minnesota night skies. And today, in fact, the entire Northern Hemisphere daytime sky as well, in a little bit of a way. My name is Thaddeus. I'm a planetarium educator here at the Bell Museum. I am joined by my colleague, Sarah, our planetarium programs coordinator, who will be giving a great presentation about our night sky. We hopefully will have a special treat, in fact, at the end of tonight, because I'm sure many of you have heard about this little Jupiter Saturn thing that's happening. We will hopefully have a live view of that we can share with you. It might require a bit of work, but I think we're going to be able to get it in, fingers crossed. But before we get to that, I'm going to hand it over to Sarah Comfort. Sarah, what's in our sky right now? What's happening? Anything cool?
Actually, yes. Unfortunately, there's a few clouds outside the museum right now. So what I'm going to do is I'm going to show you what you would see if the clouds happen to go away at any point in time over the next few hours here. So what we have is we have the sun setting over here in the western sky. We can see that the date and time are set for right now, about just after 4:30, and we can start to maybe see the moon out in the sky. And that's something a lot of people forget, is that the moon is visible during the daytime. And so we have the moon kind of over in our southeastern sky right now. But if we were to, let's say, fast forward in time just a little bit here, we can watch as the sun sets and a few more things become visible. So sun setting over there in our southwest sky, and we can just start to see Jupiter and Saturn appear here. And it's only going to take a little bit before 5 o'clock for them to start really popping out. You may have also noticed that over to the east of the moon, we have Mars starting to appear. Let's go a little bit later. Let's say, just past 5 o'clock tonight, when the sun is a little bit further set and we'll get a little bit better contrast. Okay, so now let's see here. It is a little bit later, but we can see Jupiter and Saturn in our southwest sky. Now, what's exciting here is that they're so close that here on the screen, our words are actually overlapping because they're so close. So let's zoom in a little bit here and see what it looks like in our southwestern sky. These will be about 10 degrees above the horizon, starting around 4:30, 5 o'clock. And 10 degrees is the height of your fist if you hold your arm out, your fist out at arm's length. And so it's only going to be about 1 fist above our horizon, so you'll know where to look. And if we keep zooming in here, tonight is the conjunction, the closest these two planets are going to get in our skies for about 20 years. So this conjunction between Jupiter and Saturn happens every 20 years. And they're so close that to our eyes tonight, it'll appear kind of like a double planet or maybe a really bright double star. They're so close, it'll be hard to distinguish them. But if we had a pair of binoculars or a telescope, let's see what it might look like here. And so this here is using one of the telescopes that we have at the museum. Now, this is not a live feed through our telescope because, again, it is a little bit cloudy outside right now. So this is a simulated view through our telescope, where all these planets, or these two planets and all of their moons are so close together, we can barely even tell where they are. So right there is Jupiter tonight. We can see some of the Galilean moons as well. So these are some moons that you can see through your telescope or through a pair of binoculars. You'll see around Jupiter. But just up, not too far away from Jupiter, less than a degree. It's actually, if you were to hold up your pinky finger tonight, it would cover up both Jupiter and Saturn. So Jupiter and Saturn here are about 1/10 of a degree apart. That's super duper close. That's less than a degree. And we can see a few of Saturn's moons nearby it as well. And so this would be an awesome view, and we're hoping the clouds go away so we can get a glimpse of this at any point tonight before 7 o'clock. And that's because, like the sun, these planets will set. They're so close to our western horizon, they're going to set around 7 o'clock tonight. So after that time, we're not going to be able to see this conjunction. But if we happen to miss a conjunction tonight, they'll still be fairly close together tomorrow night. So if it's not clear tonight, I'm hoping the clouds will go away tomorrow and we can see a little bit, and they'll still be close enough to see, but just not quite as close as tonight. So with this, you might be asking, what's actually happened? Are these two...
Can I jump in for a second?
Yes, go for it. I love questions.
Well, I actually don't have a question, but I just want to reaffirm what you were just saying there. There has been a ton of hype about the Jupiter-Saturn conjunction for good reason. It's very, very cool. But even if we aren't getting to see it tonight in Minnesota. It's very cloudy. Even if you don't get to see it tonight, no matter where you are, if you got to see it last night or tomorrow night or in 2 days or 3 days, it's still going to be super, super cool. Jupiter and Saturn are two amazing planets. So as Sarah was just saying, take that chance to get out there and see it. It's still going to be a very, very cool sight. All right, Sarah, back to you. I just wanted to throw that little bit in.
Okay, I want to show you what's happening here. Because these two planets are really not going to be touching. They're not going to be close enough in actual 3D outer space. What's happening here is that each planet has its own orbit around the sun. And so Earth, being closer to the sun than either of these two planets, goes around quite quickly. The Earth goes around the sun once every 365 days. Now, Jupiter, being slightly closer to the sun than Saturn, goes around the sun about once every 12 Earth years. And then Saturn goes around the sun about once every 30 Earth years. So this means that about every 20 years, Jupiter makes one extra lap around the sun and catches up to Saturn. And so that's why this conjunction happens every 20 years. Now, what's special about this one is this is the closest these two planets have been from our perspective here on Earth. We can kind of see how from Earth, our line of sight would follow just after sunset, because we're kind of on this side of the sun here. And it would go to Jupiter and see Saturn in the background. The last time this happened, this close together, this less than about a tenth of a degree here, was back in 1226. So it's been almost, 800 years since they've been this close for us to see at night. They've been this close since then, in about the 1600s, but that happened during the daytime. So these conjunctions happen every 20 years, so they'll happen more than once in a lifetime, but they don't always happen at night. And that's what makes this one so special, is that it's super duper close and it happens to be visible in the evening. Now, just because we can't see it from here in Minnesota doesn't mean it's totally lost. So here's an image from one of our friends down in Austin, Texas. And so this was taken on Saturday. Now, this is a composite image. This is a few images stacked together to kind of give us this sense of what the planets would look like through a telescope tonight. We can see Jupiter down in the lower right of this picture, and then we can see kind of going up at an angle to the upper left, we see its 4 Galilean moons. And again, you can see those through a strong pair of binoculars or a backyard telescope. And then 2 nights ago, the planets are about twice as far away as they are tonight. So they don't look that far away in this image. And tonight they'd be even closer. But we have Saturn up here kind of in the upper middle of our picture, and 4 of its moons as well. Over on the far left, we'd see Titan. And then kind of up to the upper left of Saturn, we have Dione. Then the one I cannot pronounce, Tad, maybe you remember this one. It's a Tethy moon. I cannot pronounce its name.
Is that Tethys? Is that
Tethys? Maybe one? That's how you, yep, Tethys. And then over here off to the right of Saturn is its moon Rhea. And so that's why our telescope would be so full of these really cool things as soon as the clouds go away tonight, maybe tomorrow. And by Wednesday, they'll be moving apart even further after night, but we might get a quick glimpse on Wednesday if the clouds go away any of these nights. But like Tad hinted at, we're not going to leave you hanging. We do have a way for you to view this streaming tonight, just maybe not through the Bell Museum's telescope. So hang on, because we will give you a resource to go view this conjunction from where you are shortly after we conclude our program here this evening. So that's the cool thing that's happening tonight. The other cool thing that's happening today is, of course, it is the winter solstice. So what does that mean? And Tad, I'm actually going to borrow some words from you here. So Tad put together a lovely video for us.
This is going to be very dramatic.
It's part of our Heart and Solstice programming here at the museum over the next few days. So what we see here is the Earth orbiting around the sun right now. And that yellow line, because right now we're looking at the Earth behind the sun, that yellow line is our axis, is our north-south pole. And so if we are to forward in time, we can actually pause time when the Earth's axis is tilted most towards the sun. And this happens during the summer solstice. And we can see here that the North Pole, which if we were to extend that line out all the way, would actually pointing near the North Star. And that's always pointing near the North Star. But when the Earth is on this side of the sun, that northern axis is tilted towards the sun, marking the first day of summer, the summer solstice. But as time goes on, of course, Earth is going to continue in its orbit around the sun here. That axis is going to stay pointing the same direction towards the North Star until it reaches the other side of the sun from the summer solstice. And this is when we have the winter solstice. That is today. That's when that angle that was maintained the entire time when that North Pole, though, is pointing away from the sun. Now, this also means that the sun kind of changes its height in our sky throughout the year. Because as we get different amounts of sunlight coming into our sky, the sun is actually reaching its lowest point in our sky today. And so from summer solstice to winter solstice, we can see how drastic those changes in the sun's height in our sky are. And this means the amount of sunlight coming into any one location on Earth is also changing. So when the sun's nice and low in the sky like today, it's coming at a low angle, and that sunlight is getting spread out over a large area of the Earth. So it doesn't get, no one location gets any, a lot of heat from the sun, a lot of energy from the sun to really heat it up nice and hot. But during the summer solstice, when the sun is nice and high in the sky, the top here of our image, that's when the sun's coming in more directly and it's concentrating a lot of energy and light in a smaller patch on the Earth or more directly on the Earth. And so the area under that can get nice and hot. And that's where we get those nice hot summer days, is when the sun is high overhead, directing a lot more of its light more directly to us here on Earth. But so that's actually why today is the summer or the winter solstice. It all has to do with where the sun is in our sky, and it just happens to be the lowest today. The good news is every day after day gets a little bit longer. Tomorrow is 1 minute longer than today was as far as daylight hours. There's still 24 hours in a day. But tomorrow we get 1 extra minute of daylight compared to today. Okay. But what else is happening beyond just today? Because we're here to talk about what's coming up in the sky as well. And for that, let's go ahead and take a look at our star map here. Now, you can get our star map on the Bell Museum's website. We have it there and we update it about every 2 months. So you only have to download one for every 2 months. And here is the one coming up in January. We can see here in the middle of our star map, Mars is actually going to start the month in the constellation of Pisces, the fish. But as the month goes on, and because Mars is closer to the sun than Jupiter or Saturn, we'll actually notice it's moving across the sky fairly quickly. And by the end of February, Mars here is actually going to have changed into a completely different constellation over into Taurus the Bull. But for this next month, Mars will be nice and bright and nice and high in our sky. You'll even see that reddish-orangish tint to it over near the constellation of Pisces, the fish. Now, there's some other cool things happening this month, or coming up here in January. January 2nd is actually the day where the Earth, in its orbit around the sun, is going to be the closest to the sun. Now, this kind of ties a little bit back to our seasons that we just talked about and why today is the winter solstice. But it might be confusing because a lot of people think that we're closest to the sun in the summer and further away in the winter. And that's not true. We're actually going to be closest to the sun in the Earth's orbit on January 2nd. And so that kind of just disproves the fact that summer happens or winter happens because of our distance to the sun. It's all because of our tilt, that Earth's axis being tilted. That's why we have seasons in January 2nd. We'll disprove that once again because that's when we're going to be closest to the sun, but yet it's still going to be pretty cold outside. Coming up that day as well, that night, January 2nd into January 3rd, we actually also have the Quandarians meteor shower. Now, this is a meteor shower that's actually pretty decent. It has about 40 meteors per hour that you could see on a clear, dark night. And it's actually going to be near the constellation of Perseids, the herdsman. Now, it's not named Perseids meteor shower because the Quandarians was actually an older constellation that didn't quite make the cut when the International Astronomical Union was coming up with its list of the official 88 constellations. So it's an old constellation, no longer used, but these meteors will kind of start from the constellation of Perseids. Now, to find Boötes, right now in our star map, it's a little bit below the northern horizon here. We can find the Big Dipper up in the north. And then we can arc, following the handle of the 3 stars, we can arc to Arcturus, which is in the herdsman Boötes. But just because the constellation is just below the horizon doesn't mean we won't see any meteors, because meteors can be seen anywhere across the sky. They'll just all kind of point back to the constellation of Boötes when they originate, when they emerge in our sky. But take a look anywhere at night. The best viewing for any meteor shower is on a dark night. We will have a little bit of the moon here showing up on January 2nd into January 3rd. That will add a little bit of light pollution, natural light pollution to our sky, so it's not going to be as dark as it could be. But dark nights, usually after midnight, is when the best viewing is. It also means it's cold, but anytime that night, take a look up in the sky to see if you can see one of our meteors coming through our atmosphere. Coming up, one of the best times to view things in the sky without natural light pollution is actually on the new moon. And that's coming up on January 13th. And so if you do want to go outside and see some dark sky things, or if you go out and try to take some pictures of, let's say, Mars in the sky, January 13th is going to be a great time to do it because you won't have to worry about the moon getting in your way or outshining the thing you're trying to take a picture of. And if you really want to get into it, Mike Shaw, our resident artist here, is actually going to help us learn about nightscapes in a workshop held on that night, January 13th. So if you're interested in nightscape photography, take a look at our website for Mike Shaw's workshop coming up next month. Another kind of a fun thing that's happening in January here is Mercury will return to our evening skies. So by the end of January, around January 24th, we will see Mercury a little bit after sunset. And so Mercury, being the closest planet to the sun, never ventures too far away. And so in order to see it, you want to go out just after sunset, much like Jupiter and Saturn and Mars will be some of the first things you see as the sun sets. Mercury will be one of those, but it'll be much closer to the sun. Now, never, ever, ever look directly at the sun without proper solar glasses. But to see Mercury, just wait for the sun to set and go outside a few minutes afterwards, and then you should be good. But Mercury is going to return to our evening sky kind of at the end of January, and it'll be in our evening sky just for a few weeks. By the beginning of February, it'll have continued on its orbit to the point where it's getting too close to the sun for us to see anymore. So it'll be visible just for a few weeks there at the end of January. And then one of the greatest things that is really fun to see, although it does offer a lot of natural light pollution, is, of course, the full moon. The full moon will be shining nice and bright in our skies at the end of January, on January 28th. It even can cast shadows. It's so bright to see that. But it's gorgeous to see all those craters and all those marias. You can see the light and dark. And you can use your imagination to see like the rabbit in the moon in those shapes of the maria, those dark, nice dark planes there on the moon. But those are some of the fun events coming up this next month to look forward to.
Sarah, can I jump in?
Go for it.
I got 2 questions, actually. I'm going to ask one. You were just talking a lot about all the planets, and we were just talking about the Earth and its seasons. So a question from previously, are the seasons the same on all the planets? So maybe we don't have time to go through all of the planets, because I'm sure you know the seasons on all the planets. But how about the seasons seasons on Mars the same as seasons on Earth? Can you tell us
question.
about that?
Great question. So all the planets will have seasons, and it all depends on their tilt. Now, Earth has seasons because we're tilted at 23.5 degrees. So if we had Earth perfectly vertical, we wouldn't experience much changes between the seasons. But because we're tilted about 23.5 degrees, and the Earth's North Pole is pointing at the North Star, that's why we get summer, winter, fall, and spring. And that same reason is why other planets have seasons as well. Mars is tilted about 24 degrees, so a little bit more, maybe it's 26, a little bit more than the Earth is. So its seasons are a little bit longer than Earth's are, but it has seasons for the same reason. In fact, the winter solstice for Mars happened back in September. So Mars right now in the northern hemisphere is also experiencing its winter, which means in the southern hemisphere, both Earth and Mars right now, they have summer. Because with the tilt being opposite, if one's tilted this way, the other pole is tilted that way. that the seasons in the hemispheres, north and south, are opposite each other. But yes, other planets have seasons, and it all depends on how much they're tilted, to what extent, or the exaggeration of those seasons that they do experience.
All right.
But great question.
Yeah, it's a really great question. I think we'll let people Google and maybe do a little bit of searching on their own about the planet George and what its seasons are like. There is another question. I might take this one. I mean, you can too.
Go for it.
Jenny is asking, is there an Perseids meteor shower tonight? She's got on her calendar, her space events calendar, but no one's mentioned it. And she'll also says, we have had some issues with some spammers for this event. So there is a minimum character limit on questions. You have to write at least 100 characters. So that means basically, if you've got a lot of questions, ask them all at once. Ask us a ton of questions, put them all there. We love answering these questions. It's a little bit more challenging right now with some of the technical issues, but please ask them. But we'll go back to the Perseids. Perseids? How would you say that?
It's one of the ones that never come out twice the same way when I say them. Yeah.
Do you want to talk about that? I think I might be able to jump in.
So we have many different meteor showers throughout the year. So meteor showers are actually leftover debris from comets that the Earth is just like smashing into, kind of like when you drive your car through a swarm of bugs. So the Perseids, I think the Geminids are actually coming up too, or did we just have the Geminids? I'm getting my dates mixed up.
We just passed through the Geminids.
We just passed through the Geminids.
Probably linked to that giant fireball. Incidentally, if any of you saw that giant fireball back earlier on the 16th, throw that in the comments there. I'd love to hear from anyone who saw that. But we just
heard about that fireball. I unfortunately did not get to see it in person, but it sounds awesome.
Right? So that we just left the Geminids.
Yep. So there are several meteor showers throughout the year. And each one is slightly different depending on how much debris is left over. Because if the Earth's passing through a lot of debris, we're going to be expecting to see more meteors per hour. But then some of them are pretty minor showers, and that there's not as much debris we're flying through. So there's not much debris flying into our atmosphere, burning up. That's what those shooting stars or those meteors. It's rocks and debris from outer space burning up through the friction with our atmosphere. And so we just passed the Gemini, so you might have seen them, but that just because it's not in the middle of a meteor shower, it doesn't mean you can't see any shooting stars or meteors, because there are those random ones that fly through our sky all the time. Okay, and it looks like here that Tad has shown us where the Perseids originate. Again, you can see them anywhere across the sky. Just because you can't see that particular constellation, or that doesn't mean that's the only constellation to look in. So Perseids here is Ursa Minor. The Little Dipper is part of Ursa Minor. That's where the meteors will start to look like they're coming from. But again, they streak anywhere across the sky, so you can keep looking wherever views that you have at home.
And the Perseids as you were saying, it's a more of a minor meteor shower. If you're really tracking them backwards, you'll see that they come from this region of the sky here around the Little Dipper, the Little Bear. But in general, I think that this is one that sort of just adds more to the dynamicness of our night sky. It may not be quite like the Geminids, but it's still a nice one to go out and give you a little bit of extra little something to see. It's a small little stocking stuffer for the night sky this time of year.
Yep. Okay, so I do have one other I do want to put a few things on other people's radar, because we are coming to our end here. And again, we're not going to be hanging. It is cloudy here, but we have a way for you guys, or we're going to suggest a way for you guys to see that conjunction between Jupiter and Saturn here in just a few minutes. But before I turn it over to how you can see that at the conclusion of this, I want to share with you a few more cool things to look out for in our evening sky as we move into the new year. And so what we're looking at right now is a part of our star map. And so we can see the constellation of Orion right here in the middle, recognizable by the 3 stars that make up his belt. We have Betelgeuse making up his shoulder. The star Bellatrix, the female warrior star, she's one of my favorites, is over here in his other shoulder. And then Rigel and Saiph make up his knees. So those are going to be the easy stars to see even from here in the cities. So what you can do here is you find Orion. We're going to go from Rigel in Orion's knee up to the bright star Aldebaran in Taurus the Bull. And that's going to be kind of an orangish star. And again, it'll be one of the brighter ones in our sky. We can recognize Taurus the Bull from this kind of V shape here, marking his face and the horns of the bull. But from Aldebaran, we can then hop up to Capella, which is another really bright star. I've even heard reports, people noticing that it's twinkling red and green right now and it's low on the horizon shortly after sunset. So take a look. This star really does twinkle gorgeous colors when it's low on the horizon. Then from Capella, we can continue star hopping over to Castor and Pollux, the two brightest stars in the constellation of the Gemini twins. From those two, we can hop down to Procyon, the brightest star and only one of two stars that are really in the constellation of Canis Minor, the little dog. Now, if you look here, Canis Minor is just those two stars. It is just a single line. I've heard some people joke that it doesn't really look like a dog, but it looks maybe like a hot dog in the sky. And from there, we can jump down to the brightest star in our evening sky. This is Sirius, at the heart of the dog constellation, Canis Major. So we can see the dog's head here, Sirius at the heart of Canis Major, and the front legs, and then continuing below the horizon here. And these constellations get higher and higher in the sky as the winter goes on. And to complete the circle, we can jump back to Rigel. So by star hopping, we can connect these constellations with what's called the winter circle. It's kind of not quite a perfect circle, as you can see here, but it's a great way to star hop from something you do know to try to find a few new things in our winter sky. And it's a gorgeous sight here. The stars are shining and twinkling quite bright. As the winter does go on, the temperatures get colder, and that just really makes the stars pop and shine better because the Earth's atmosphere is a little bit more stable when it's so cold. But take a look at these things. I don't want you to miss out on some of these bright, gorgeous sights in our winter sky here. And with that, I think what we're going to do here is we're going to tell you where to go see the conjunction. Because again, it is cloudy out. I'll look outside the window here in another few minutes, but I don't really have much hope for us to see it here in the Twin Cities because of those clouds. But we do have friends down at the Emily Buehler Planetarium at Seminole State College down in Florida. They're going to be joining one of our events come February. And so what we want to do for you guys is they have clear skies as far as we've been told and we've looked up. And so we're going to point you guys to go see their Facebook Live event. And they're going to be streaming it and talking about this conjunction. So even if you can't see it from here in Minnesota, go take a look, and they'll be streaming things from where they are in the clear skies of Florida. So enjoy the conjunction, everyone.
All right, Sarah, the link just got posted for that. So everyone watching, check out the chat there. But we got a question from Nancy. So before we leave,
yes.
For the last people sticking around, Nancy asked a really great question. Sarah mentioned that the stars twinkle different colors. So I think we're talking about a Capella there. Some people were seeing some different colors. And she asked, what affects the colors of the stars? And does the same star twinkle different colors?
Okay.
So would I expect to see different colors from Capella if it was higher or lower, or is it always the same? Are stars different colors?
Okay. Well, there's so much information in this. I know we only have about a minute left, so I'll give you the short answer. One, stars come in from all different colors. If you go out into space, they come in red, orange. Our sun is a yellow star, yellow whitish star, white and blue. So the stars come in all different colors on their own. Now, the reason stars appear to twinkle is because we're on Earth, and the light has to go from that star in outer space through the Earth's atmosphere to our eyes. And it's the Earth's atmosphere that makes that light kind of waver and twinkle. And so that's what's happening. The stars themselves are not twinkling. Now, the reason why Capella looks like it's twinkling all these different colors is one, it's one of the brightest stars in our sky. I think it's like the 6th brightest star in our evening sky. And when it's low on the horizon, the light from that star is coming through a bunch of atmosphere, and that makes it twinkle even more. So over the course of the night, as Capella gets higher in the sky, it's not going to quite twinkle as much as if you see it right around the horizon as it's rising or setting. And so that's why it's going to see those big bright colors. One, it's so bright, and two, it being on the horizon, it'll twinkle more than it does when it's straight overhead. And that's just the Earth's atmospheric effect. That's the short answer.
So that's a great answer. And as you were saying, there's so much more. Star colors are so intense. There's so much more to go into it. But just a question myself here. If I see something twinkling in the sky, and it's moving and it's coming towards me and it's got some weird noises coming from it, what do you think that is?
It depends on how close. If it's really close, it's probably your neighbor flying a drone at you.
Oh, okay. All right.
But usually when you see something twinkling and moving in the sky, it's going to be an airplane. If you see something in the sky that's twinkling and not moving, it's going to be a star. But if you see something in the sky that's not moving and it's not twinkling, then it's a planet.
So what are the chances we'll see aliens? Any?
That we'll see aliens?
Yeah. Could it be an alien? A spaceship?
Very low.
Oh, okay.
I mean, it might be a UFO, an unidentified object to you because you don't know what it is, but somebody somewhere on the Earth does. So the idea that we're going to get a UFO flying at us anytime soon is very unlikely if that it's going to carry actual aliens to a different planet.
All right. Well, I'll keep my fingers crossed. Okay. I think our link is there to Emil Bueller's live stream. It's there in the chat. We'll throw it up again. It is. I did check. It is clear skies. It looks like beautiful skies down in Florida. That's the way it goes. So I hope you all. That's where I'm headed. Actually, I'm headed to the live stream. So I hope to virtually see you all there in some way. For a very cool sight through their telescopes. And I want to mention that gifts of this program and all the work we do is made possible in part through gifts to the Bell, donations, and your help is always appreciated with that. So if you have anything to donate, if you have the means, we really appreciate that so we can keep putting on programs. And when the sky clears, put our telescopes to some very good use. But with that, I would like to thank all of you so much for joining us here tonight. I hope that you're all staying safe and staying warm. And I hope that you're having a safe holiday season or whatever, or if you're celebrating anything. And Sarah, any last words?
Happy Winter Solstice, everyone.
Happy Winter Solstice. All right. Have a great night, everyone. See you in the Florida live stream.